Hi, everyone. I'm going to give you a short introduction to the SEM here in the SEM laboratory, okay? Hang on for a second and we'll take a look at this. First of all, I want to show you the SEM itself. Can you see it? From the outside, this is the electron column. So electrons are emitted from an emitter at the top here, and they accelerate across a high electric field, and then we have a beam of electrons that travels down through the instrument. You can see some other things from the outside as well. This is the X-ray spectrometer that we're going to use for our electron dispersive spectroscopy to identify elements. This is something that we won't use called wavelength dispersive spectroscopy. It's another type of X-ray spectrometer, okay? This is the vacuum chamber that holds the samples underneath the electron beam. We'll look at that in a second. And then finally, all of this down here are just the vacuum pumps and electronics for the instrument, okay? Here, let's open the door. All right, we're gonna pause for a second. You can see inside, it's a little hard to see because it's so dark. So let's see if we can fix that. Okay, there we go. So now we're looking into the instrument, and you can see a couple of things. The main thing you can see here on the top is you can see what looks like the bottom of a cone. That cone is the bottom of the electron column. So at the center of that is a hole, and the electron beam comes out of that hole, goes directly down to hit the sample. Another thing you can see over to the right is a silver tube. That silver tube, a little hard to see here. X-rays which leave the sample can travel up that silver tube to reach the X-ray spectrometer we were looking at a second ago. Finally, on the bottom here, you can see a place where a sample can be mounted. And then that sample holder is on a 3-axis stage here, which allows you to move the sample anywhere around inside of the chamber under computer control. That makes the whole thing very easy to use. Okay, pause for a second here. I think I'll point out this poster here, which shows many of the things we were just talking about. Okay, this is a diagram showing the inside of the electron column. At the top here is the electron gun. There's actually a hot filament inside of this, and electrons are emitted by the hot filament, and they can travel through a small hole in this cone. And then they accelerate across a large voltage drop. In our case, it will be, I think, 20,000 volts. After that, the beam is focused by electromagnetic lenses, which allow both focus and control of the electron beam. The electron beam is brought to a first focus at an aperture here. This defines the beam spot. And then it's brought to a second focus onto the sample. In addition to being focused here, the beam can be scanned back and forth using electromagnetic deflectors built into this part of the apparatus. And the way the machine works is that the electron beam is scanned over the surface of the sample. Let's see, can we still see that? I guess I better tilt this down a little bit. Scanned over the surface of the sample. And then we look at the current of reflected or emitted electrons as a function of position to make up our image. Okay, since the electron beam is scanned, that makes this a scanning electron microscope. Some other things you can see in kind of cartoon picture here are an electrode where secondary electrons that are emitted by the sample can be collected. That's what we're going to use for our imaging. You could also use backscattered electrons to do much the same thing. And finally, X-rays that are emitted by the sample can go up to our X-ray spectrometer to do EDS, electron dispersive spectroscopy. All right, let's pause.